Hello everyone and welcome to this machine learning playlist. Today we are covering an important topic, so whether you're someone who is absolute beginner or you have some experience with machine learning, this playlist has been designed in such a way that it will be easy to follow for everyone. Also packed with lots of values and information, and it will be really helpful for you, especially if you're preparing for a machine learning based job role like data analyst or data scientist. So please subscribe to the channel and drop a like below to support our work. And without any further delay, let's get started with today's topic.
Welcome to this new lecture where we are covering extreme gradient boosting algorithm. This algorithm is an extended version of the previously discussed gradient boosting technique. In case you have missed the previous lectures, we have covered gradient boosting technique in details in separate lecture for regression and classification problems. So as a prerequisite for you, I am expecting that you are familiar with these topics. In case you need more clarity on that, please consider checking those videos out. I will provide you the link below in the description box. Also, we are going to use this particular data set for demonstration purpose in order to understand how XGBoost actually works. And this data set has the value of age on the x-axis and the likelihood of winning medal on y-axis. For simplicity purpose, I have kept the data points limited. So there are only 4 data points, which is indicating that when the age is between early 20s to early 30s, there is a high chance of winning medals. And when you are extremely young or very close to 40, the chances of winning medals is reducing. So using this particular data set, we are going to take a step-by-step approach in order to understand that how XGBoost algorithm works and trains the models sequentially one after another. The very first step would be to do an initial prediction. And in case of XGBoost algorithm, by default, that initial prediction value would be 0.5. As the next step, the next model will try to fit a regression tree to these data points. However, please keep in mind that trees used by XGBoost algorithm is completely different than what we have seen earlier. So over here, each tree starts out as a single leaf and all of the residuals or data points will go to the leaf. What I mean is, when we are training the next model, it will start the tree as a single leaf. So I will try to draw it correctly. Okay, not that correct though. And all the data point values will go inside this leaf. So I will place all the values here. Okay, done. And then we calculate something called similarity score or quality score for this particular leaf. So let's try to explore this entire flow in more details ahead. So you can see this is how the tree is starting out as a leaf and all the data points are being placed within that leaf node. And this is the formula of the similarity score that we are going to use, which says sum of residuals and then we will square it off divided by number of residuals plus lambda, which is a regularization parameter. So we have 4 data points that we will place here and then we are taking a square of it. Number of residuals, we have 4. And in order to keep the explanation simple, for the time being, I'm keeping this lambda value as 0. If you do the calculation, we get a similarity score or quality score of 6.25. So this will be the similarity score of this particular leaf node, which is 6.25. Now the further approach of the algorithm would be, is there a way that we can do better in order to increase or modify this similarity score value by clustering similar data points into groups? Then of course it is possible. Let's go ahead and we will see how. But for the time being, please keep in mind that when we are keeping all the data points within one single leaf node, the similarity score is 6.25 that we are trying to improve further or increase further. And in order to improve this value, we need to split this tree ahead. But the question is that what condition we will be using in order to split this tree. Coming back to the data set, this tree can be splitted ahead using this point or maybe this point or this point as well. So this point is falling somewhere at the value of 15. This point is falling at somewhere around 22.5 and the next point is falling at the value of 30. So in order to improve the initial similarity score, we are going to take 3 attempts with these 3 points in order to split the tree further. So first we are trying to check with the condition of age less than 50, and using this same formula we are calculating the similarity score. And remember, the initial similarity score when we applied all the data points within the same leaf was 6.25. And since we have two similarity scores now, we are going to use a measurement term called as gain value. And this is the formula for gain that says similarity score of left leaf plus similarity score of the right leaf node minus similarity score of the root node, which means this plus this minus this one. If you do the maths, you will get a final value of 468.75. So this is the gain when we are using the condition of age less than 15. And after checking with the age 15, we will check the same thing with age 22.5 and age 30. And finally, we will compare that which split is doing the best. So when we are checking with the condition of age less than 22.5, the gain is 6.25. And of course, we don't need to discuss anymore that how these similarity scores are being calculated. But there is one thing to observe here, that your similarity score will be extremely less when the residuals in the leaf node are very different from each other. If they are absolutely equal and opposite, like plus 18 and minus 18, then the similarity score is going to be 0 using this formula. Anyways, the point is that when we are using the condition of age less than 22.5, then the gain is 6.25, which is not doing any better than the initial similarity score. So we are done checking with the splits of age 15 and age 22.5. Now we will check finally with age 30. And when we apply this condition, we get a gain value of 374.08. So this is the value for an age condition of less than 30. This is the value of gain when the age condition is less than 22.5. And this is the value of gain when we are using the condition of age less than 50. Of course, comparing all three, this particular gain is the best that we can achieve. And therefore, we will use it for the first branch of the tree. And now, after splitting using less than age 15, we will do the further splitting over here on the right leaf node. So when we try to split further this particular leaf node, we can use two conditions, either 22.5 or age less than 30. And these are the respective gain values with these two conditions. And since this one is the higher gain value, this is why we will proceed ahead with this condition only, and we will ignore this part. Also notice that we are limiting the tree depth to 2 levels only. So this is level 1 and this was level 2. However, in contrast, by default, it can go up to 6 levels when you are solving a real life problem using XGBoost algorithm. However, since our final tree is ready now, barring this particular part, let's understand a couple of more important things here. Yes, we are going to discuss about how do we prune this tree in order to tackle overfitting. So the simplified idea is we prune an XGBoost tree based on its gain values. So there will be a term called gamma. And again, this is a term which can be regularized. But as of now, let's consider its value as 400. And what we do is we start calculating the difference between the gain associated with the lowest branch that we have here and the value for the gamma. And after doing this calculation, let's suppose that the final value that we get, if that is a negative value, in that case, we will prune the tree. However, if that is a positive value, in that case, we will not prune the tree. So let's try the same for this particular example. So we will do 793.5 subtracted by 400 equals to 393.5. And of course, since it is a positive value, we are not going to prune this particular branch. And therefore, the other nodes on the top will also be not pruned. Or simplified terms, we are not going to remove it. But for a minute, just consider that this difference, in case it would have been a negative number, in that case, first of all, we will cancel out this particular branch. And then we will again check the same for this branch where the gain was 465.75 that we calculated earlier. So we will check the difference between this and the gamma value. In case that again turns out to be a negative value, we will cancel this entire tree. So ultimately, the key point is the difference between the gain value and the gamma term has to be positive, and then we will not prune the tree. Also, if you remember that previously when we were calculating similarity score, we kept the alpha value as 0. So I will quickly show you instead. I am talking about this particular alpha value from the similarity score formula. If you remember, for simplicity purpose, initially we kept this value as 0. However, when this value increases, let's say this value, we are considering it as 1. In that case, going by the formula, you can understand the value for the similarity score will start decreasing, and so does the gain. In simplified terms, if you are increasing the value of alpha, you will have a lesser value of the gain and similarity score. And when the gain value is very less, let's say for example 200, and you are subtracting the gamma value out of it, and let's say for example it is 400, then it will lead to a negative value. So what I'm trying to say is, when you are increasing the alpha value, it becomes easier to prune leaves because the gain values are smaller and will lead to negative difference of gain minus gamma. And also the increasing value of alpha prevents, or at least helps to prevent, overfitting. So please do not think that if we are pruning the tree, then it is a bad thing. Of course not. If we prune the tree at the right time, then it will help us to achieve an efficient model by tackling overfitting, which means the efficiency of the model to perform good on the unseen data will increase. However, for now, let's move our focus from the lambda and gamma values, and let's assume this entire tree that we are working with to determine the output of the values for the leaves. So the way we have 3 values within this leaf, 2 values within this leaf, we also need to calculate that what will be the output for this leaf. So the output of the leaf is calculated using this simple formula that says sum of all the residuals divided by number of residuals plus the regularization term lambda. So using this formula, let's try to predict the output for this leaf node right here. Since there is only one residual within this leaf node, so we do not need to sum up anything. So I will keep it as minus 20 divided by number of residuals, which is 1. And for example, let's keep the lambda value as 0. In that case, the output as well will going to be minus 20. However, in contrast, when we change the lambda value from 0 to 1, in that case, the output will be changed as well. So it will be minus 10. So as of now, ignore this particular part and we will assume the value of lambda as 0 only. So the output value will be minus 20. Exactly the same as the residual value within this leaf node. And using this particular value, now if you do the prediction, then your prediction would be initial prediction plus a small learning rate multiplied by the output value, which is minus 20 in this case. So let's place the values here. Do you remember the initial prediction that we had? It was 0.5 in case you don't remember. So placing the values over here, I will place 0.5 as the initial prediction. Plus, I will keep a learning rate of 0.2 multiplied by the leaf output, which is minus 20. If you do the calculation, the output will be minus 3.5. And this value is indicating that we are actually moving towards the right direction. How? Because the actual value was minus 20 and the initial prediction was 0.5. That was really bad prediction in terms of the actual value. But now with this prediction of minus 3.5, we have actually started moving towards the right direction of minus 20. I will also show it on the figure. So this was the actual value, minus 20. And this was the initial random prediction, which was 0.5. And now after training the model, it says a prediction of minus 3.5, which means we are actually getting closer to the actual value. And likewise, the new prediction for all the remaining observations here, here, and here will start moving towards the right direction from the initial prediction and will have lesser residual or will have lesser error compared to the initial prediction, suggesting each small step was in the right direction. So all we need to do is we will keep on building trees like this until the residuals are super small or we have reached the maximum number of trees that we can build within the XGBoost algorithm. So let's summarize quickly what we have done so far. When we are building XGBoost model for regression, we calculate a similarity scores and gain to determine how to split the data, the way we have done over here. Then, if required, we will prune the tree by calculating the difference between the gain and gamma term. We prune only if the difference is a negative value, otherwise we will not prune it. Then using a specific formula, we calculate the output values for the remaining leaf nodes the way we have done here. And lastly, we have also discussed that lambda is a regularization parameter, and when the lambda value is increasing, it results in more pruning by shrinking the similarity score and gain value. So I hope that you were able to gain some understanding around the topic of extreme gradient boost algorithm. With such algorithms, we are moving towards the advanced machine learning topics. So please expect slight difficulties in order to gain a foundational grip on boosting algorithms. And I also suggest that you watch these lectures at least 2 to 3 times to build the intuition around it. The next lecture is going to be around XGBoost for classification problem. So I would suggest that you consider pressing the bell icon. You will get notified as soon as I upload the new lecture on the channel. And also a small request would be to subscribe to the channel if you are not yet subscribed, because to be honest, it takes a lot to create and record these lectures, and it feels really motivating when I see the subscriber count increasing. So that was it for today's video. Thank you very much for watching till the end. You have a nice day ahead.